Okay, so let's this time we're gonna deal with using our different logarithm properties to either expand or condense logarithmic expressions. All right, so we're gonna use either or all of those. All right, such as what? The zero log rule, identity rule, product, quotient, power, or change of base rule. In some cases, we're also going to use the inverse log rules, part 1 or part 2, whichever is needed, okay? Let's try to answer number 17 for this first, right? Let's read the instruction first for such, okay? Aiden, go ahead, please. Let's read the instruction.
For the following exercises, use the properties of logarithms to expand each logarithm as much as possible. Rewrite each expression as a sum difference or product of logs.
Thank you, right? So we're gonna condense this one to expand this logarithm, right? So we can use either sum, difference, or product of logs, okay? Yeah. So in short, that's the product rule, quotient rule, or power rule for logarithms, right? Let's try number 17. Okay. First of all, what do we do with number 17? First of all, if you see a square root, means what? Like when you say square root of k means what? It's k to what power? 1/2. Very good, right? That is correct. Very good, Celia. So with that being said, if you see that square root, then we can write it such: logarithm or common log of what? X cubed y negative 4 raised to what power? 1/2 power, right? Once again, that is what we call our power rule for logarithms, right? Power rule for exponentials, right? Okay, power rule for exponentials. Next one, if you see x cubed y negative 4, we can write this one as a quotient between what? By negative exponent rule, this can be written as what? X cubed over y's fourth. Very good, right? That is correct. Again, do not forget the 1/2 power. And that's again common log, right? Are we good, guys? Okay. Now, since we have used our power and negative exponential rules for such, let's use our log rule now to expand this one, right? First of all, what you're gonna do with the 1/2, right? So we're using still the, what you call this, the PEMDAS or order of operations for such. We're gonna start with the exponent, okay? Parenthesis and exponent, right? What you're gonna do with the 1/2 in terms of logarithm? Anyone? What rule should we use? If you have a what? If you have an exponent on a logarithm, what's gonna do with the exponent, guys? Put it in front of the logarithm, right? Very good, Candy. So in short, this 1/2 by log power rule, okay? Put it in there, right? So that's gonna be equal to what? 1/2 logarithm x cubed over y4, okay? Are we good? So again, by log power rule, okay? Next one. Well, the x cubed and the y4 are what? What rule should we use for those? Quotient rule, right? So what you gonna do with those? Should we add them or subtract them? Subtract. Very good, Eva. So with that being said, by quotient rule, quotient to log rule, so this can be written as what? Log, what's that? X cubed minus log y4, right? Raised to, this one is what? Times 1/2. Are we good, guys? Good? Get it what we did? Get it what we did? And the last one. What do we notice in here? We still have a power on the x and a power on the y. What we're gonna do then for those two? Put it in front, right? By power rule, we can put this what? In front in there by power, right? Good. So with that being said, that can be written as what? 1/2. What is this then? 3 log x. Very good, Madeline. minus, what's this gonna be? Log y4 can be written as what? 4 log y. There we go. All right, yeah. We're almost done in here, right? So basically just distribute the what? The 1/2 on the 3 and on the negative, right? And that's basically our answer, all right? 3/2 log x minus 4/2, or basically just 2, right? Just 2 log y. And that's the final answer for such. Are we good, guys? This time we're gonna do the reverse, right? What if we have an expanded log, but this time we're gonna compress it, right? Compress it or condense it as a single logarithm, right? Let's try it in here, number 20, right? Let's read the instruction first for number 20. Anna, go ahead. For the following exercises.
For the following exercises, condense each expression into a single logarithm using the properties of logarithms.
Thank you, right? So this time, you are given the expansion, you're gonna condense it into a single logarithm, right? Let's try number, what's that? 20, right? Let me put it in here. Number 20 is as such, right? What's this? Log, what's this? Common log 2x fourth plus common log 3x5. And again, this one, we're gonna condense. Okay, first of all, if it's a plus of those two logarithms, what rule should we use? Should we use the product rule or quotient rule?
Product.
Product rule, very good, right? So in short, by product rule, because this is a plus, product rule, so this can be written as what? Common log. Now what you're gonna do with the 2x4 and 3x to the 5th? You're gonna multiply them instead, right? So what's that gonna be? 2x fourth times 3x to the 5th power. Okay, right? And then after that, we're gonna use our rules and exponents for that, right? So what you're gonna do with the 2 and the 3? Multiply them together. What's that gonna be, Thomas? 2 times 3? 6. Very good. What you're gonna do with x4 and x to the 5th by exponent rule? Add the 4 and the 5. Very good, right? So that's gonna be what? X to what power? 9 power. Okay, so that's it. We have already condensed it into one single logarithm, right? So we are gonna stop in the condensing if it's already a single logarithm. But in the expansion, we're gonna stop when the x and the y are already what? No exponents, no nothing in there. Are we good? Questions regarding that one, guys?